Hello everyone, welcome back to the Avalon game project. Last time we have finished implementing the DynamoDB repository and the com service. So now we have to, by finishing that, we basically finished all the core stuff. Now we're implementing a few things just for the purpose of interfacing with the infrastructure. I myself have created the first Lambda function here. This is basically just for creating a game. So it's very simple. We simply create a game based on the payload we receive. This will be hosted behind a authenticated endpoint. So once we have the game, we have a couple of more things to do, a couple of more Lambda functions to implement. So piece by piece, after create game, the second part is for the players to join. So in this case, we simply would just create a new function called create game. This is join game or player join game. I think join game makes more sense. So this would be almost exactly the same as create game, with a slight difference of so when we create the game, as you can see here, we only create a repository and create a game ourselves. But when the player actually joins the game, so the game already exists. And remember, in the state machine, we actually have a state called game setup state, where it handles the player joined action. So here in this Lambda function, we have to initiate the state machine. So basically, let's copy paste everything. So these are just boilerplate. Code. So here, of course, we'll have a try catch, except. So let's just get the boilerplate in place, and then we can focus on actually implementing everything. So for initiate the state machine, first we have the repository, and we'll have the com service. So here the com service equals to socket com service. So with those, now we can finally create a state machine. So now, state machine, what else comes to repository and game ID, of course. The game ID, we will have to receive it from the request. So So what we do is so we assume the anyways. So here I would like to explain a little bit. Here we assume the request would be something like HTTPS slash API gateway domain slash this here will have a game ID, then we'll have a player, and this or join. So this would be so we will get the game ID from the path parameter. Okay, so here here the path parameter we can get it from path params equals we can get it from the path parameters. And then we can get the game ID from the path parameters. Return 400. So now with the game ID, we can create the state machine com service repository. Okay. Game ID. So now we'll have to create an action. So join game action equals to action. So this action is also from game core. And action, we have a couple of things we need to have. First is an ID. We can give it a random ID. So now think about it, the action, we really don't need an ID, but anyways, so let's still give it some. ID equals to UID, the UID for the hex. So we have to import this. The next one is the game ID. Game ID, of course, just equals to game ID. We have it. Player ID. So we'll have to, okay, so we have to create the player ID here. Let's take a look. Game setup state. So we have the action, then we handle the join game. In the join game, we save the player. We get the game ID from here. The payload, what we're looking for is just the name. So the name will receive, of course, So we should also check it here. So we get the game ID from the path parameters. Then we get the name from the request body, which is done by body equals JSON.loads. Actually, okay. We verify we do have the player name. The action type, of course, is action type dot join game. We have to import action type. Just type is action type and the what we're expecting, the just name. So name is player name. So now we have game state machine dot handle join. Was it handle? Yeah, handle. Nope, state machine. Set up handle action. Okay. Dot handle action join game action. Okay. Join game action. So now this part is done. Okay, so we're returning this. So if everything's ready, we are going to return so the player is joined, and we return a couple of different things. So at this point, we will have to give back a game ID. will have a player ID and okay, so we better have it here because we do need it. Okay, we have the player ID, and last but not least, WebSocket endpoint. So we basically return all these. So by this, the player would know the game ID, the player ID, and they would then, we expect the front end then to use this WebSocket endpoint to actually connect to the endpoint. And now, so I'm not ready to test because I don't want to interrupt the continuation of explaining things. So once we have this, we will have to implement another function called onConnect. This method is also a Lambda function, handles handles when the user actually connects to the when it connects to the WebSocket. So remember, so here, when we connect to the WebSocket, we will have to, as we agreed, we will use the DynamoDB to save the connection ID of the player. So as we can see here, we have implemented something to get connection ID. The connection ID, basically the primary key is the game ID, and the sort key is connection ID underscore player ID. So we'll have to insert this record on connect. So do we have this implemented? Repository. No, we don't have it here. Get connection, put a connection ID, yes. So all we need to do is call this. Here we need a game ID, player ID, and a connection ID. The connection ID, we could get it. So the game ID and the player ID, we expect all those from the query parameters. So connection ID, we can get it from the connection ID, we can get it from the event request context dot Then the parse string parameters equals this. Then the game ID we can get it from there, and the player ID we can get it from there. Now, if not connection ID or game ID or player ID missing, so we'll have to return 400, and we definitely want to log out this what has been missing. So we just want to log the actual query string params, like what are we getting. So once we finish the validation, so actually it's a good practice. It's a good practice to put everything in the within the try catch, because in this case we know when anything goes wrong, and we basically gives a well, 500 is not graceful error message, but it's much better than exposing our internal logic. So now we have everything. We just want the repository to actually put in the connection ID. Once we have that, we can just give a 200 and an empty body. Yeah, so we have finished this, and the only thing left is that we need to implement So apparently this put item would override whatever is in it. So the next thing we're gonna implement, the next and the last thing last method we're gonna implement is for the actually another thing, but anyways, so the next thing we're gonna implement is to actually get the events. This is in case someone lost their WebSocket connection and need to reconnect, and then they'll have to fetch all the events just for reconstructing the whole thing. So so we'll have to create a new thing called get events. And again, we can just copy paste the boilerplate stuff, delete everything here. Of course, not this part. So so because this is the get method, we will have to verify if basically first of all we assume that the URI, in my opinion, would be something like HTTPS API gateway domain slash game ID and player ID, then events, things like this. So so we get the game ID and the player ID from the path parameters. Um, hmm. So I also want to get the player secret from the headers. So remember we gave the player, so let's take a look at the player entity. So we gave a secret just for the player to identify him or herself. We probably want to do it here as well. Yeah, not really worth it because on connect it should be fine, but here when we get the events, just in case, I mean this is a very naive way of identifying someone, so let's just put it there for the sake of it. So player, we can get it from the repository. We can just get it from player ID. Then wait. So here, when we join the game, the player ID is not just a player ID. It's actually so player service. So how do we define the player ID again? Sorry, I forgot. No, we have to look at the repository. Join game. We put in the action, the player ID. So this is not great. We are implementing the same logic in two places. A good way of doing this is to basically extract the player ID logic somewhere else. But let's not dwell on that. Let's just implement this very simple logic. So player ID, it's actually yeah, this. Right. So let's get this to the get events. Player ID. Yeah, in this case we know it's player ID. So if player dot secret not equals to player secret, invalid secret will return error. Actually, this would be a for one because it's not properly authenticated. So once this is done, we will use the repository to get all the events. Don't we have that? Put event. We have put event, but we never have get events. This is bad. Okay, so we must miss something. So repository, put event. After that, I wanted to add a get events, and of course we need a player ID. So here we'll have to implement it. After the put event, we will have get events, game ID and the player ID. And it's a list of event. So we need to query event ID. Yep. Yeah, PKSK, then recipients equals to item.recipients. So if the player ID in recipients, so actually if recipients equals to empty array or the player ID in recipients, we're gonna actually get it. So we'll return this. So event, I remember we have a to-dict perfect. So once we have this implemented, we can come here, get events. Not model dump, rather to-dict, then just JSON dumps. Okay, in this case, it get all the events. Once we have that, so now we need to implement a default handle the default route. Here is actually handle action. I think let's just call it on action, right? So now again we want to get the boilerplate from create game. Actually, join game might be much better. So let's we implemented get events. Let's delete this. We don't need that. We don't need this. We don't need this. Okay. And we have the on action. Paste everything here. What we need to do is, of course, we need the game ID, we need the player, we don't need the player name actually, doesn't really matter. We get this. Okay, so the game ID will no longer be in the path. So we have the game ID will be within the message. So what we will have to do is to get the event. In the message, we get the game ID, we get the player ID, and we get the action type, and we get the payload. So now with all these, we will be able to we will have to create an action ourselves. So action, the action will be something like type would have a type, so ID we have a game ID equals game ID, player ID equals player ID, we have action type, and we have a payload. And then we will ask the game state to actually handle the action. So afterwards, we don't want to do anything, let's just return empty body would be suffice. Cool. Yeah, I think today we made some pretty good progress. Of course, that's because we didn't write any tests. I'm sure some of this code is not is problematic. So I think next time I'm gonna wrap up here. So I think the next time what we're gonna do is to, of course, add all the tests to these lambdas. Once we have verified everything is okay, we will move on to actually working on writing the code for deploying this to AWS. So the framework we're going to use is called SAM. I will have more information prepared when it actually comes to it. So yeah, today I'm just gonna I think I'm gonna wrap up today. Thank you everyone for watching, and see you next time. Bye.